And finally, page 8, problem 20. There's a radical, cube root radical, but it's not isolated yet. So we'll start by taking away 3 from both sides. We'll have cube root of 5x minus 2 equals negative 3. And we proceed. We don't say no solution because this is negative. Since this is an odd index root, you take an odd root of a negative number, you get a negative number. So this is going to have a solution. How do we get rid of a cube root radical? We cube both sides. We raise both sides to the third power. Doing that on the left side just leaves us the 5x minus 2. And on the right side, negative 3 to the third is negative 27. And if I add 2 to both sides, I get 5x equals negative 25. And divide both sides by 5. Get x equals, it's a negative divided by a positive. Watch the signs. Negative 5. Which does work. Let's just see that real quick. If we plug in a negative 5 here for x, 5 times the negative 5 would make a negative 25. And then we'd still have minus 2 plus 3 outside the radical. Does that truly add up to 0? Yeah, because this is negative 27. And the cube root of negative 27 is negative 3. Negative 3 plus 3 does equal 0. So that takes care of that. Okay, down we go to here. Isolate this radical by subtracting 5 from each side. And you don't get 2, you get negative 2. You get the fourth root of 3x plus 1 equals negative 2. And you kind of sort of could stop right here and say this is impossible because you got an even index root coming out a negative number. This is impossible. That would mean that something to the fourth power gives you a negative 2, and that's just not possible. Not a negative 2. Well, never mind, I'm getting tongue-tied. Let's get rid of this radical by kicking both sides up to the fourth power. Fourth power of the fourth root of 3x plus 1 is 3x plus 1. And negative 2, negative number to an even power is positive, and 2 to the fourth power is 16. If we take away 1, get 3x equals 15. Everything looks nice and normal. Divide by 3. Get x equals 5. That's a nice little number. When you plug it in, though, it doesn't work. Because when you plug in a 5, it's going to say fourth root of 3 times 5 is 15. 15 plus 1, and then plus 5 equals 3. Impossible. Because you're going to add 5 to something here and get something smaller than 5. That would mean this would have to be negative. And just like the square root, fourth root, we understand that that means only the positive number whose fourth power would be, in this case, 16. See, this is fourth root of 16 plus 5. And the fourth root of 16 is only 2, not negative 2. Negative 2 to the fourth does give you positive 16, but we're not allowed to use a negative 2 here. The meaning of this symbol is primary fourth root, only a positive 2. 2 plus 5, last time I looked, was 7, not 3. So we say no solution here. Okay, and that's the end of page 8 and the end of Wednesday's work. Have a good day.